Okay, so here's a practice test. So we'll
Mm-hmm.
go through, and the more you guys interact, the better off you'll be. It'll help you with some of the questions. Okay, so number one, why do chemists use models of atoms and molecules?
Use models more convenient on this.
Well, okay, so A, models uses so use of models is more convenient and less expensive than the use of photograph of microscopes. B, matter at the particulate level is too small to be seen. C, chemists follow a tradition established by Watson and Crick. D, high-powered electron microscopes create computerized models of the atom and molecules. E, to illustrate books and scientific papers with more color than black and white photographs of the atom and the molecule. Which one do you guys think it is?
Maybe matter at particulate level is too small to be seen.
That is correct. Okay. Which of the following are elements? We have I, K, O, H,
I think it's
I.
the last one.
You think
E.
it's the last one? Okay.
Yeah.
What about NE?
Yeah, that one
Me,
too.
That
So
one.
that one, the third one, and then the last one.
So do you think the third one?
No,
Capital
no,
C,
no.
capital
Yeah,
O?
that one.
This one here?
CO.
C, or are you sure? Isn't that
pizza.
a capital C and a capital O?
Um,
That one's like a like what do you call it? Like a compound, I guess.
That's a compound. That's right.
Yeah.
Because it represents carbon and oxygen, right? So
Yeah.
we're talking about an element. An element is only going to be a single type of. So you're going to have the capital and the lowercase, right? So the correct answer is D, which is IV, calcium, and neon.
um,
Okay. What about number three? It says, which of the following substances is slash are heterogeneous? Gasoline, a O bar, a freshly opened can of Coca-Cola, potato chips, a strip of bacon.
Is it potato chips?
So you said freshly potato chips. Okay. Anything else?
A bacon strip. Wait,
Okay,
because heterogeneous, that's like where you can see the differences, right?
that's right. So
Okay.
you said a bacon strip. You have potato chips. Anything else?
A freshly opened can of cola. Yeah, the can of.
Yep, that is correct. So that would be number or B, right?
Yeah.
Okay. So which of the following does not describe a mixture? Two or more pure substances, distinct set of physical and chemical properties, components that can be separated by physical change, boiling temperature of a solution will increase with time. All of the above describe a mixture.
Isn't it boiling temperature?
So that technically that is true. I mean that technically that does describe a mixture. Right?
I
Could it
think
be
they
all
all,
the above described mixtures?
That's right. The
yeah.
correct answer is all the above describes a mixture. Yep. So we know that if we add something, let's say to water, that's going to cause water to have to boil harder, you know? So like salt, it increases its boiling temperature by us adding just salt to it. Okay. Number 5.
It was that one. I think it was carbon dioxide and sodium carbonate.
Okay. So you said compounds, sodium dioxide, and
And
sodium carbonate. I mean, carbon dioxide and sodium carbonate. Okay.
Yeah.
So that's 1 and 3.
yeah.
Okay. Do you guys all agree?
Yes.
Okay. That is correct. Okay. Number 6. Which of the following properties is distillation based upon?
Boiling points.
That's right. Okay. Number 7. Which of the following statements is false? Both elements and compounds are pure substances. B. Properties of a compound vary. C. An element cannot be decomposed chemically into pure substances. E. A compound cannot be separated into other substances by, I'm sorry, a compound can be separated into other substances by chemical means. E. All the above are true. None is false.
Would it be the first one?
So that is false.
Yeah,
Oh,
because while elements are pure substances, and
yes,
while compounds, they're not like, they can be broken down into elements, which are pure
they
substances.
they can, but aren't they also pure substances? Because if
Oh,
I have pure sugar, all of the
yeah.
molecules.
Can it be C?
Okay, it says C says an element cannot be decomposed chemically, not nuclearly, chemically into other pure substances.
It's a compound can be separated into other substances by chemical means.
Okay, so chemically, can't we break down a compound to, like, for instance, water to oxygen and hydrogen chemically?
Yeah.
Yeah.
Yes.
So then what do you guys think the answer is?
So it's all of the above.
All the above. Okay. Complete the following operation. So we're going to subtract these two. What do you guys end up with? Testing your calculator skills here.
So for those questions, would you also want us to show our work?
Yeah, so it's always good to show your work, because if, let's say, you enter the wrong, you rented the wrong thing and you end up getting it right. So what I do, I sometimes I'll go through and I'll give you those credits.
Okay.
Does that make sense?
Yeah.
So would it be 7.12 times 10 to the negative 11?
Nope.
No, that's not it. Oh,
Nope.
man.
Because remember, this is just subtraction.
That was the first one.
You said it's the first one?
Yeah.
Nope. It's not the first one. It's not the second one. Remember, this is just subtraction, not division. So it's just subtraction. So literally, I have 9.370. And then in your calculator, you guys are going to write 9.370 EE. And then you're going to put, it's going to be parentheses -5. So how many of you guys are currently using your phone or a calculator? So
I
you guys
have a calculator.
I'm using my
type
phone.
in 9.37, and then you're going to type in 70 EE, or you'll see EXP, or you'll see, sometimes you guys have times 10 to the whatever. And then you're going to put in, there's a negative symbol, not subtraction, but just a negative symbol, and 5. And then you're going to hit subtract. Or you'll see on my phone, it says plus minus instead of that negative symbol. So it'll say plus minus. But on my calculator, it uses a negative symbol. And then we're going to minus 2.25 EE. You're going to hit plus minus, or sorry, minus, yeah, plus minus, so that you have a minus.
Could it be D?
The correct answer is D as in donkey. That is correct. Do you guys see that?
Yeah.
Okay, so make sure you guys are using the right operator. So just minus, not division. Okay, so a fixed amount of gas at a constant volume. So for a fixed amount of gas at a constant volume, the pressure P of the gas is directly proportional to its absolute temperature. Which of the following is the best choice of units of the proportionality constant that would relate pressure and temperature in the equation? Okay, so ATM is going to represent pressure. I just thought about this. You guys should probably get this one for free if you get it on your exam, because we haven't talked about the units for ATM. ATM is atmospheres, so that's going to be the units for pressure. Temperature is going to be, it says absolute temperature. So anytime it says absolute temperature, it's making reference to Kelvin.
Oh,
Okay, so we know that this one isn't going to be correct. We know that this one isn't going to be correct, and this one is going to be correct. So we have two choices. So if we're saying that P is going to be proportional to T, and this means that it's directly proportional. So as P goes up, T goes up. To make these equal to each other, we put a constant, K, and they want us to find the units of that constant. So if T is going to be in what units? Since we know that, what units is it going to be in?
Okay.
Okay. So we're saying K, capital K. So we want to figure out the units for this guy. So is it going to be K over ATM, or ATM over K? Or is it going to be equal to ATM?
ATM over K.
That's right. So it's going to be ATM over K, right? Because if it's the other way, we get K squared. We don't get rid of K. So we want to be able to get rid of K to get our ATM. So we know that our constant has to be ATM over K. Does that make sense?
Yeah.
Yes.
Yeah.
I have to rewrite that question so you guys know that ATM is a unit per pressure. Let me clear my screen. And then we'll start on number 10. Now, be careful with this one. I'd say have a ruler available if you have a ruler. Okay. It says, what is the value of x when y is 2? So here's y. We go over.
Be 3.75.
Okay. Okay. That is correct. Okay. Number 11. See, I'm going to have to make that bigger because I can't see it. There we go. Okay, so what we can do, let me give you guys a hint for this one. So this one is a positive 4. This one is a negative 4. Since these are all multiplication, so they're going to be multiplied by each other. So we can just multiply those exponents by each other. Since this is a positive 4, we're going to end up with a negative 4 here. Right? Because this is 4 times that 10 to the 4th to 10 to the minus 4. That's just going to equal 10 to the minus 4. These are going to cancel each other out. So then all we're going to have to look at is just this number divided by this number and divided by that. What do you guys end up with?
D, the last one, the last option.
You said D?
E,
E.
the last one.
No, that is not correct.
0.24.
Yeah. So it's this one. So we want to be careful when we enter our numbers, right? So anytime that you have 10 to the minus 4, and we can just temporarily just ignore these numbers, right? And then we have 10 to the 10 to the 4th. And we also have 10 to the minus 8, right? So since these are exponents, what we can do is just make them, and they have the same base. So we can say just 10, 4 minus 8 on the bottom. Okay. So, and that's going to be equal to what? Isn't that going to be equal to 10 to the minus 4?
Yes.
Okay. So that's what we're going to have at the bottom here, right? So I'm just going to substitute, and that's going to be equal 10 to the minus 4 over 10 to the minus 4. Okay, so then that's going to cancel out. So in other words, we're going to be just left with these numbers. So if we're left with those numbers, you just type in 4.77 divided by 2.73, and then you can divide that by 7.11.
Okay.
And what do you end up with?
So all we have to do is just get rid of the exponents first and then just
Well, in this case, it's easier to do it that way. Or you can enter all of them. When you enter it, you would go 4.77. And then you're going to use your EE. You're going to put a minus there. So you're going to use that plus minus to put the minus there. And then you're going to enter 4. And then you're going to hit divide, parentheses. And then you're going to do this one here, 2.73. You're going to use your calculator or phone, EE. 4. And then you're going to go times 7.11 EE, that plus minus symbol, 8. So then it gives you a minus 8.
Mm-hmm.
And close your parentheses and then hit your equal, or what is it? Execute, or yeah. And so you should end up with this value.
Yeah, yeah.
Yep.
Mm-hmm. Thank you.
Okay. You're welcome. Okay. Let me clear my trash. Everybody got that? You guys ready to move to the next one?
Yes.
Okay, so let's go up. Here's our next one. Distance and time are directly proportional for an object moving at a constant speed. What is the value of the proportionality constant for a car that travels 133 miles in 2.5 hours? Okay. So the first thing that they tell us is distance and time are directly proportional. Okay. So how would I write that down? And we can use D and T for distance and time. How would I show that they're directly proportional?
Would it be through division?
Yes, that would be true. It would be through division. But if I wanted to say that they're directly proportional, the easiest way of saying that is we're saying D, just little d. D for distance. And then we're going to say it's directly proportional to time. Okay. Yeah, excuse my third grade handwriting. There you go. Okay. So this symbol represents directly proportional. Now, if we have a constant, we can say a constant K. Again, that's our constant for everything. We can make it equal to each other. So distance is going to be equal to KT. Okay. So then if we're looking at our units, the units for distance in this case is going to be what unit?
Miles.
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 So we want to end up with miles. So we're going to have miles on top for our units for our constant. And then on the bottom, so that the time cancels out, our time in this case is going to be hours. So on the bottom, for it to cancel out, it has to be hours on the bottom. Because we're saying this here represents the units for our K. So then our time is always going to be in hours. Hours divided by hours is going to cancel out, and that's going to equal miles.
Miles.
Right? So then that means that our constants unit has to be miles over hours. So do we have anything that's miles over hours?
The 53.
Yes.
Okay. So then that would be our answer.
So I have a question. If it says indirectly proportional, would it be multiplication?
Yeah, so if it's indirectly proportional, well, yes, it would be multiplication, or we could say, again, in this case, we'd say 1 over. Let's say we're not going to use time. Let's use here we go. We'll use frequency, right? 1 over frequency is going to be indirectly proportional. So we'd write it like this to lambda. So 1 over lambda is going to be indirectly proportional to frequency.
Like
Right?
wavelength.
Okay. Yeah. So that's the symbol for frequency, right? So then in this case, we're going to put a K here. So in this case, we know our K is really our C. So then we'd say, or our K value. So in this case, we have K and frequency, and that's going to be 1 over lambda. Okay. So does that make sense?
Yeah.
Okay. And so, and then I'm sorry, that should be equal, not fix this. So this should be equal because we're saying our K is going to be okay. So then we're able to get our units. So if we know the units of our frequency, so we want to get rid of those units. So that's going to be on the bottom. And then that means that this guy is also going to end up being on the bottom as well, too, because this is 1 over lambda. Okay.
Okay, thank you.
You're welcome. So which of the following is the best mathematical expression to represent the fact that pressure at a constant volume and temperature is directly proportional to the mass of that gas?
That would be A.
Okay. So we're saying it'll be A. That's correct. Okay. And so that would be how you show you're directly proportional. Now, if they put a constant here, right, that could give us another answer. That would be correct. But they don't have the constant there. So that's the reason why that one is wrong. Okay. Good job. Okay. So the next one, it says convert 9.16 kilojoules to gigajoules, hectajoules, and microjoules. And these are the conversion factors. Okay, what do you guys think we're going to do?
Do we have to divide?
Okay. So by what? So what I always do is I'll start off with what my given is. So that's my 9.16. I say kilojoules, kilograms, not kilojoules. It has been a long day. So I'm going to be converting grams, right? So I know that this is kilograms. So do I have a value for kilograms to grams? Anybody know how many grams are equal to 1 kilogram?
10 to the third.
Okay, so we know that 1 kilogram was going to be equal 10 to the third grams, or 1,000, right? Okay, so then we'll say 1 kilogram on the bottom, 10 to the third grams on top. And all of these are converted in grams. So we can start off with the giga. So we want gigagrams. So it says for every 1 gigagram. So we're going to have gigagram on the top because that's the units that we want. Capital GG. and then we have 10 to the 9 on the bottom, grams. So those grams are going to cancel out. Kilograms are going to cancel out. And so we end up with, so here, since this guy's on top, it's a positive value. This guy's on the bottom being divided by. They're both factors of 10. So then we could sit there and say 9.16 times 10 to the, and this guy would be 3 minus 9. So what is 3 minus 9?
6 or -6.
-6. Okay. Okay, and that would be gigagrams, right? So we'll have 9.16 times 10 to the -6 gigagrams. Okay, so which ones can we get rid of? Looks like we can get rid of this one, we can get rid of this one, we can get rid of this one, and we can get rid of that one. So our correct answer is that one. Okay. Questions? Okay, let's keep going then. Our next question. So let's scroll this up. Number 15. It says, determine if it is a physical or chemical reactions / property. Cracking a glow stick,
Chemical.
Chemical.
boiling water,
Physical.
adding Mentos to soda.
Physical.
Chemical.
It's actually physical.
Physical.
So all you're doing is allowing a surface area for the gas to escape. Okay.
Chemical.
Rusty nail.
Chemical.
That's right. Okay. Okay, significant figures. Determine the number of significant figures of the following.
3.
Okay, so we know that only the non-zero numbers here are going to be significant. What about this one?
3.
Okay, what about this one?
5.
How did you figure 5?
Honestly, I just counted like how many fractions of numbers there was, and I just went with 5.
So you're just taking a gamble, huh? So
Yeah.
actually what you need to do is add them up. So let's put them in order. We're going to put them in, and then we need to line them up. So we're going to line them up, and then we'll add them up.
So we line them up with the decimal, right?
That's right.
Okay.
Okay, and let's see, 1, 2, 1. Oops, that is not lined up. 2, 1, 0, 0. Let's see. And the last one is 100. Okay, so after you get them lined up, we can go ahead and do the math. So you get 4, 0, 0,
5, 0, 0, and then it'd be point. And we get 10. Then it'd be 2, 3, 4, 5, 6.
so that's 4.
Oh wait, no, 5.
Shouldn't it be 4? Because this is the 10 spot. So it's 1.
Oh yeah, I added the other one on the other side.
Yeah,
And
but
then
isn't this over? Yeah. So then it should be 1,
2, 1.
2, 1. Okay. Okay. So now what we're going to do is we're going to line up. So you're going to line up the one that is furthest to the left of non-significant numbers. So here, significant ends after this guy, right? Here, significant ends after that number. And then here, significant ends after the 4. Here, significant ends after the 0 because we took the extra time to add that 0. Here, significant ends right after the 1 because there's no decimal point or anything like that. So it'll be right here. So then we'll take a look at this number. If that number is greater than 5, we're going to round the number up, the next number up. If it's not greater than 5, we're just going to drop this down to 0. And so then our answer is going to be 1, 2, 1, 0, 0. So then how many sig figs would this be?
Isn't the 100 a negative?
What was that? Oh, you're right. Sorry. I'm glad you caught that. So I just added everything. So let's fix that. So if we add 100, we're minusing 100. So then it'll be
Be 1,002. Well, 1,200.
so
So instead of the 1, it'd be a 0, right?
Yep. So now that 1 will be a 0. Right? But would this guy still be significant? This one right here. That I had the line over. So we'd probably write it in scientific notation. So it'll be 1.20, right? Because this is where significance would actually end between here. So that number, that O is going to be significant. So I'd write it as 1.20 times 10 to the 4th power. So then how many sig figs does this guy have? This number.
Is it 3?
It would be 3. That's right. Because this 0 is now significant because we have those decimals there. Okay. Now what about this one? How many sig figs should my answer have?
Is that one also 3?
That one is also going to be 3 because it's always going to be the lowest number of significant figures. Okay. Guys ready for the next one?
Kinda.
Kinda.
That one's a long one.
Yeah. Yes, this next one is a long one too. Okay, so let me clear.
So I think in that one there was like 3 separate answers, right?
Yep.
There was the answer for hours and then gallons and then the Celsius and the Kelvin.
That is correct. Yep.
And I think I got it, but I'm not sure.
Okay. Okay.
Should I tell you the answers or like the whole problem?
So let's work through the problem. So let's
Okay.
work through the problem so that everybody else can see the problem. Because just seeing the answers isn't going to help us, but working through the problem will. Because we don't know that we're going to get the exact same type of the same question. We know that we're going to get something like it, but we don't know it's going to be the same.
Okay.
Okay, so the very first one, it says Your car is leaking gasoline at a rate of 0.025 per minute. If your car has a 12.00 gallon tank and is full, how many hours before your car is completely empty? Okay, so we want to start off with our given. So what is our given?
The 0.0250 gallons per minute.
So that would be our conversion, right? Because that's changing one unit to another unit. So that's going to be representing our conversion. So that's going to be the second thing that we use. So the first thing that we should use is what?
What I did was I did the 32.0 miles per gallon, and then that was on the bottom, and then on the top I had did the 75.0, which was the
Okay,
miles per hour.
slow down because we're working on the first part, right?
Okay.
You're already on the second part. So I need you to come back to the first part.
Your
So
constant 12 gallons.
12 gallons is going to be my given, right? So we're going to start off with 12 gallons because there's only a single unit. And that's the way I always like to start off. We want to start off with what our starting, right? So 12 gallons is what we're starting off with. Let's put our units down there. Sorry. Okay, that's gallons. So I'm going to use gal for my abbreviation. Okay, so now we can use our conversion factor. So what are we trying to get rid of? Are we trying to keep gallons or are we trying to get to time?
We're trying to get to the hours. Well, yeah,
Okay.
time.
So then that means that we want time on top because that's what we want to get to. So then I'm going to adjust this. So I'm going to put my 0.025 on the bottom. And that's gallons.
Mm-hmm.
Okay. And I'm going to put 1 minute because per minute basically means just 1 minute on top. Okay. So then my gallons cancel out. So my answer should be in minutes. But do I want minutes?
No.
No, I'm asking for hours. All right. So I want my unit in hours. So what is the conversion for minutes to hours? Or hours to minutes?
Is it 2.34375?
Okay. So what are the units to convert from minutes to hours?
I had put 0.0250 gallons per minute, and then over
60 minutes.
60 minutes. Okay.
Yeah.
So you slow down. You're a little too much ahead because we're trying to show each step, right? Okay.
my
So we
answers are all
want
over the
60
place.
minutes on the bottom. But that's okay. I mean, that means that you're thinking. You're definitely thinking. And then we have 1 hour on top. Okay. So then we're able to get rid of minutes. And since we want 1 hour, that's always going to be what we want should be on top. Okay. So then our answer is going to be in hours, an equal sign. So then all we do is multiply across. So we have 12 times 1 times 1. And then you divide by what's on bottom. Okay.
Mhm.
So what did you guys end up with?
For the hours, like the final answer?
Yep. You can give me the final answer now.
Okay. I got 0.00213 hours.
Are you sure?
Not sure, but that's what I got.
Okay. So I'm going to tell you that's incorrect.
Okay.
I got 8.
You should end up with 8. And there's
8,
4
yeah.
significant figures here. So then we should end up with 4 significant figures. So it should be 8.000. That's a decimal point there. Okay. So if you start off with your given, because we're starting off with gallons, we have 12.00 gallons, right? We're going to divide it by 0.025 gallons, right? So those gallons are going to cancel out. That's going to leave me with minutes. So if you do that, that's going to give you something like 480, right?
Yes.
Okay. And then we can divide that by 60. So the number on top, so what you would do is this line here represents multiplication. This line here represents multiplication. This line here represents division, right? So anything that's on the bottom, you can multiply them by each other, right? And then you're going to take that 12.00 and divide it by what that number that you got on. Or you could just go through each step. 12.00. In this case, you're multiplying it times 1. Then you're dividing it by this value. Then you're going to be multiplying it by 1. And then you're going to divide it by that value.
Dr.
Okay.
Henry, do we have to write all of that?
Yes. If you want full credit.
Oh,
Because
yeah.
if you mess up, then I can't see what you did. And I can't give you partial points, right? So you always write full credit, all of it, you know.
Oh, okay.
I see what I
I
did
just
wrong.
put 12 divided by 0.0250 and I put equals to 480 and then I did like just 480 divided by 60 equals 8 hours.
Yeah, that would be fine too, because you broke it up into each point. That's fine.
Okay.
Yeah.
Okay.
Okay. Okay, so we've gotten that part down, right? So we that's our first one. So if
should
you're
it be
driving,
4 sig
Oh.
figs or 3 sig figs?
so this would be 4 sig fig, because these guys are going to act as conversion factors, and we always know that anytime that we go minutes to hours, those are going to be conversion factors. You don't use those to determine your significant figures. So you want to start off with the number of sig figs that you started off with in your given. Okay,
Okay.
but that's a good question. Okay, and so if you're driving from Fireball to Salinas, which is 101 miles, to see your new bay, you met in chem class at a speed of 75.0 miles per hour. So that's one thing there. Here's one thing here. Would you make it before you run out of gas, assuming your car gets 32 miles per gallon? You started with a full tank, okay, of gas, and your car is still leaking gasoline at the rate that was mentioned above. How many gallons of gas are left over or short? Okay, so, and it tells you, please show your work to support your answer for full credit. Okay, so here we're going to be looking for what ultimately? What is the final thing that we want to know?
We're looking with the gallons we started with, the gallons that were consumed, and then how much gallons leaked.
That's right. Okay, so we want our starting gallons. How much are consumed by traveling? So that we're going to subtract our travel gallons. And then we're also going to subtract our leak gallons. So that's how we're going to get to how much is going to be left over or short. Okay. So let's start off with our starting gallons. How many gallons are we starting off with?
We're starting with 12.00 gallons.
Okay, 12.00 gallons. Okay, so how would I calculate my travel gallons? Put that over here. Okay, what are some of the things I can use to calculate my travel gallons?
Distance.
I'm going to use my distance, so I'm going to use that. I'm going to start off with my distance. So I have 101 miles.
Over 30, would that be 101 miles over, well, under 32.0 miles?
Okay, so we're going to put the 32, oops, not minutes, it should be miles. MI, okay, my bad. And then we're going to put 32 on the bottom. That's what you're telling me? To get rid of miles, right?
Yeah.
So we're going to get those units, and then we want to get gallons. Okay, so then that's going to cancel that out. So that's going to give me my gallons. That's traveled. So I'm going to subtract that. So what is that? Guesstimating approximately 3, something like that. A little more than 3. 3.15. or 3.16?
Isn't it 3.156?
Yeah, but here we have how many sig figs? Because we're starting with 101.
He rounded up.
So it should be, yeah, it's 3.156, but we're going to round up because we only have three significant figures. Okay.
Oh, okay,
And
okay.
that would be, yeah, so that would be travel gallons. So what about our leak gallons? How can I calculate that?
Would it be 0.0250 gallons per minute times the 1.34667 hours times the 60 minutes per hour?
In our case, it's 75 minutes per hour. So that's what you're telling me. So you're saying, let's see. So we have 0.025,
50.
okay, 0 gallons per minute.
Mm-hmm.
And you're saying that we travel,
Would it be 60 minutes per hour?
60 minutes per hour. So we're going to 60 minutes on top to get rid of our minutes. 1 hour on the bottom. Okay, so that gives us hours. And then you're saying to use the 75 0.0 miles on the bottom. And then we're going to have 1 hour on top. Right. So then that gets rid of hours. And so we're going to end up with gallons per mile. So then what is the distance that we're traveling? Isn't that 101 miles? So we should have started there as well too. So then that cancels out our miles. So if we do that math, 101 times 0.025 times 60 divided by 75.
Point zero two.
Say that one more time, please. You got
Point
202?
02 gallons.
So 2.02?
Yeah.
Okay. Okay. So then altogether, so did we make it?
Yeah.
Yes, since it's a positive value, we made it. And then we end up with 6.82 gallons left over. Okay. So that will
I
be
was
your,
close to that answer.
you were
What I
close?
got was, yeah, I got 6.8125.
Okay. 6.8125. So then you would round up, right? So then you end up with 6.82 because you want three sig figs in this case. When you add them all up, it'll be right
Yep.
after here, right after there, right after there. So you should end up with three sig figs. Okay. So that's the second part. The third part, we're converting 325 degrees Fahrenheit to Celsius and to Kelvin. Okay, so how would I change it to Celsius? What is that equation?
5/9, the bracket F minus 32.
Okay, so you said 5/9 degrees Fahrenheit minus 32. Should it be this in parentheses?
Yeah, that's what I was about to say. Can we put parentheses 325 minus 32 parentheses times 5/9 Celsius?
Let's see. Okay, so you're talking about for Kelvin or for?
Yes, for Kelvin.
Okay, yeah. So this is the equation that we're going to be using to get Celsius, right?
Mm-hmm.
So let's get Celsius first. Let's take them one at a time, right? So then we have the Fahrenheit, degrees in Fahrenheit, so 3. So that would be 325.
Yeah. But it wouldn't be 325 minus 32.
You said it would not be.
I'm asking because that's what I had put on my question. I had put C equals parentheses 325 minus 32 parentheses times 5.9 Celsius.
5 divided by 9. Yes, but you're not put because Celsius is what you're going to end up with, right? Does that make sense? So you're going to have 325 minus your 32, and then you're going to divide or multiply by 5 divided by 9. Okay, so we plug in our values. So in this case, so we said 5/9,
Mm-hmm.
and we have 325 minus 32. Oops. So we end up with, we plug that into our calculator, we end up with 163 or 60.
It's 62.7, but if you round it up, yeah, it's 163.
Degrees Celsius.
Mm.
Okay. And then to change this to Kelvin, we go 163 plus 273. And you can use 0.15 if you want to be exact, or you can just use 273. It'll be fine. And
Then it'd be 435.93.
435.
So would I be wrong then if I wouldn't round it up? Because I didn't round up any of my answers and I still got it similar to that, but just like without the rounded amount answer.
So in terms of the temperature, I'll give you leeway because temperature is kind of weird in terms of sig figs. And so I'd give you leeway with that one.
Yeah, because
But for the other ones, I wouldn't give you leeway. You want to use the number of sig figs. So in this case, that would be 260, or sorry, 460, 436 degrees. 436 Kelvin.
okay.
Okay. Make sense?
Yeah, it makes sense. I just need to round up my numbers.
Okay. You guys ready for the next question? Did everybody get this down?
Yeah.
Okay, let's do the next one. Okay, so how are we going to do this? So what elements do we have in our chemical equations? In this first chemical equation.
Carbon, hydrogen, and oxygen.
We have carbon, hydrogen, and oxygen. Okay. How many carbons do we have on our reactant side? So well, first off, which side is the reactant side and which side is the product side?
The left is the reactants and the right is the products.
Okay. And so technically this guy is over here. Drives me crazy that it does that. Okay. So how many carbons do we have?
12.
12. How many hydrogens do we have?
22.
22.
How many oxygens do we have?
11.
11.
No,
Plus
2.
13.
13. Okay. On our product side, how many carbons do we have?
1,
How many hydrogens do we have?
2,
And how many oxygens do we have?
3.
1. 3, 3, 3.
3, right? Because we have the 2 here and we have the 1 down here. Okay. Okay, so I'm going to erase all of the lines showing you where everything is at. So since we know where everything is at now. Okay, so what do I need to multiply my carbon dioxide by so that I would end up with 12 carbons on my product side?
$12.
Okay, so then that would give me 12 carbons. How many oxygens now?
It'll be 24.
Okay, so that'll be 24 plus,
Oh, plus the 1, 25.
25. Okay. Okay, so then how many hydrogens? So what do I need to multiply my water by so that I would end up with 22 hydrogens on my
11.
11? Okay, so now we have 24 plus 11. Is that 36? I mean, not 36, 30, 35.
What was it?
For the oxygens.
25 plus 11.
24 plus
36.
11.
Oh, yeah.
Okay.
It's 25. 35. Sorry.
Okay, so on the other side, we have 13. So our hydrogens are looking good. What was that? Okay, our hydrogens are looking good. Our carbons are looking good, but our oxygens, okay? So since you have an odd number here and an odd number here, what do you guys think we're going to need to do? How many are we definitely getting from this compound? From the sugar, from this compound, how many
11.
oxygens are we getting? We're getting 11, right? So that one's going to already be taken into consideration. So if I have 35 minus 11, that's going to give me what?
24.
24, okay? Okay, so we need to get 24 oxygens. So what do I need to put in front of here so that I can get in front of the oxygens so I can get 24?
12.
12, okay? So I'm going to put 12. 12 here. And then I'm going to put a 1 here because even though normally we don't put a 1 there, we need to put a 1 here so it lets me know that there's 1 because otherwise it'll screw up. So one of the bad things about using Canvas. for exams. Okay, so that would be our answer. So it'll be 1, 12. This would be 12. That'll be 11. Okay, what about the next one? Okay, so we know here's our arrow. So all of these guys are on the other side. Okay, so then how many nitrogens do we have on our reactant side?
We have one.
How many hydrogens do we have on our,
4.
how many Cl?
4.
1.
And then how many oxygens?
4.
4.
Okay, on our product side, how many nitrogens?
2.
2.
How many hydrogens?
1.
2.
2.
How many Cls?
2.
And how many oxygens?
3.
3.
Is it balanced?
No.
No. Okay, so what do I need to do to balance it? Start with those nitrogens. How many
Yes.
nitrogens do I have? How many nitrogens do I have on my product side? And how many do I have on my reactant sides? And what can I do to make them so that they're balanced?
You can multiply by 2.
Okay, so I'm going to put a 2 in front of my compound. So then that tells me I have 2 nitrogens. Now, how many hydrogens do I have?
8.
That's right. 2 times 4 is 8. Okay, how many chlorines do I have?
2.
2.
3. Oh,
2.
no, 2. Yeah, 2. Yeah.
And then how many oxygens?
Is it 8?
Yep, 8. Okay. Okay. So is that balanced?
No.
Okay, so what do I need to do to balance it?
Multiply by 4.
Yeah.
What are we going to multiply by 4?
The hydrogen.
Hydrogen.
The
So,
hydrogen. 2 times 4.
okay. So we're going to put a 2 in front or a 4 in front. Oh, you said a 4 in front. So we're going to put a 4 in front of our water. Is that what you're telling me?
Yes.
Okay. So then it'll be 4 times 2, which would be 8. And then how many oxygens do I have now?
1, 2, 3.
So it's 4 times 1, right?
4, 5, 6.
So we have a total of 6. That's right. Okay. So is that balanced?
No.
So what else do I need?
You can multiply by.
Because everything else
You
is
can
good,
make it.
right? The
Yeah.
nitrogens are good, hydrogens are good, the chlorines are good. So it's just those oxygens. So what do I need
What
to
do you-
put in front of this?
2.
A 2. Okay.
Mhm.
So then that would give me a total of, we have 4 here and we have 4 here. So that'll be a total of 8. And then we're going to put a 1 here because the computer program won't recognize it otherwise. That'll mark it wrong. Okay. How are your brains? How are your brains right now?
Fried.
Oh, mine too.
Yeah.
I've been up since 4:30 this morning, so I'm exhausted. Okay, so let's see. We have enough time. Now we got enough time to do a few more. Okay, it says the average temperature of a hot car is 200 degrees Fahrenheit, and your car heats up to 325 degrees Fahrenheit. If your car needs 6 quarts of oil with a specific heat capacity of 22.27345, and that's joules per gram Kelvin. Okay, now here's a key, a hint to us. This is temperature, Kelvin. We have Fahrenheit. Okay, so we want to maybe change those to Kelvin so the units match up. And the density of the oil is going to be 0.852 grams per milliliter. Okay, so what type of unit is quarts?
Is it volume?
Volume. Okay, so we have 6 quarts of oil, and we know that if we're planning to calculate, they want us to calculate how much energy would bring it back to normal volume. So in other words, we want to calculate our Q value. Q is going to be equal to mass times the heat capacity times the change in temperature, or like I like to say, MCCAT. Okay, so we need to figure out the change in temperature, but we need to make sure, because this is our specific heat capacity right here, we need to convert these into Kelvin. So the first thing that we want to do is convert Kelvin. So if I remember correctly, 325 degrees from my question that I did before, I think it was what? 436 degrees Kelvin. Because that was in the question that we answered before. So that's going to be 325, right? And then 200 degrees Fahrenheit. So I know I'm going to change my Fahrenheit to Celsius first. So I'm going to subtract 32, and then I'm going to multiply that by 5/9, and then that's going to give me my degrees Celsius.
Mm. 93.3.
Okay. So I'm going to go ahead and add to that 273.15. And what do I get?
Uh, 366.5.
Okay. So now we know our delta T is going to be final, T final minus T initial. So we have, so that's 433, 436 minus 366 6.5 Kelvin. So then delta T T there.
70. Well, if you round it, 70. If not, it's 69.5.
Okay. Okay. So approximately 70 degrees Celsius, Kelvin.
Kelvin.
Okay. And then our specific heat capacity, we already have. So we need to change our quarts into milliliters. So how many quarts are in a gallon? Is it 4 quarts equal 1 gallon?
Yes.
Okay. So then quarts are going to cancel out. We have gallons. And then we know that for every 1 gallon, we can use our conversion table. Let me see if I can pull that up here.
$3.785.
3.785. Okay, thank you. Five, and that's liters. And then we want milliliters. So we know that 1 liter is going to be 1,000 milliliters. And then we can use that density, right? Because that gives us this density right here, which is 0.852 grams per 1 milliliter. Okay, so our milliliters are going to cancel out, our liters are going to cancel out, our gallons are going to cancel out, and our quarts already canceled out. So if we go ahead and multiply across and then divide it by the that's at the bottom, so we have 6 times 3.785 times 1,000 times 0.852, and we're going to divide it by 4.
That's 4,837.23.
Okay, so our mass, it says 4,000.
837.23.
Not a long walk.
I missed one. There we go. Is that correct? $4,800. Okay. Got it. Okay. So, and that's grams, right? So let's go back to our problem here. So we can see the other side. So now all we have to do is plug everything in. So we have 4,837. And then, and if we're going with sig figs, since I was lazy and I just put 6, that would be an exact number. So you can get away with using. And that would be grams. We're multiplying that by our specific heat, which is 22.47345 and that's joules, grams, Kelvin. And then we're multiplying by the change in temperature, which was 70 degrees Kelvin. Okay, and let's see, what do we get?
I got 108,704.01. I mean, 0.1.
You got, say that one more time.
It's 108,704.1.
Okay, so
Well, if
I
you
got
round,
something a little
round to the
different.
rest. Okay, hold on. Let me try it again.
Okay.
Okay, I forgot to multiply by the temperature.
Mm,
So yeah, I got that. Yeah, the same.
okay, so 7.609 times
Uh-huh.
6. Yeah.
Yeah, 1, 2, 3, 4, 5, 6. Yeah, when you move it. So the answer should be in scientific notation.
Or you can write it out. If you want to write it out, that's fine. So that would be 7,690,000 and something else. Yeah.
Uh-huh. Okay, thank you.
Okay. Questions?
No.
Okay. So let's move forward. Okay, I'm going to erase. Okay, so a substance that melts at 123 degrees is probably a network solid, an ionic crystal, a metallic crystal, a molecule, a molecular crystal, or a. Okay, so you guys haven't really talked about this. So if you get this question, I'm going to give you a freebie. Um, and so the answer in this case would be a molecular crystal. The melting temperature of it is so low that 122 degrees is kind of like what water melts at, or not water boils at. So let's see, 122 degrees Celsius. So if it's a metal, it's going to have a much higher melting temperature. So like most metals melt well above 100 degrees. So we're talking about in the thousands of degrees. Ionic crystals, they take a lot of energy to melt as well. Network solids is it's a mesh of things. They're pretty high in melting temperature as well. So the one that you're talking about is probably your molecular crystal. So your molecules are probably going to melt. That means they're covalently bonded. They're not as strong interaction forces between them. So it's going to take less energy to take that apart. So your correct answer would be there. And so again, if you guys get a problem like that, I'll give you guys it'll be a freebie. It should be in your exam. It may pop up by accident. Okay, so calculate the specific heat of an unknown metal if 123 gram sample requires 8.8 kilojoules of heat to change from 16 degrees Celsius to 97 degrees Celsius. So you guys are going to use this equation again. Q equals MCAP. Or Q equals C delta T. So in this case, we have our specific heat. We have our heat, we have our mass, and we have the change in temperature that we can calculate. We're looking for our specific heat. So we're looking for our C value. So in this case, we want to modify our equation so that we solve for C. So you're going to basically get C is going to be equal to Q divided by M delta T. Here they give us our Q. It's in kilojoules. So we're most like, I guess we could leave it in kilojoules. That'll be fine because then our units would be in kilojoules. No, we need it in joules because our unit here is in joules. So the first thing that we want to do is change our kilojoules to joules. So we have 8.8 kilojoules. We need to change that to joules. So we're going to divide that by, or multiply that times 1,000. So 1 kilojoule is going to be equal to 1,000 joules. Then we're going to divide that whole thing by the mass, which is 123 grams. And then our delta T, which is going to be 97 minus 16 degrees C. So then when we're left with our units, we should end up with joules, grams, degrees Celsius. So if we go ahead and do that math, what do you guys end up with?
I got 0.883269680919.
So 0.88.
Yeah.
Okay. How do I get all the way to that? Okay, so number 23. Here. Number 23. What is the total heat flow if 27 grams of steam at 123 degrees Celsius, 143 degrees Celsius is cooled to become water at 34 degrees Celsius. The specific heat of water is 4.18 joules per gram degree Celsius. The specific heat of steam is 2.0 joules grams degrees Celsius. And the heat of vaporization of water is 2.26 kilojoules grams. And the boiling point of water is 100 degrees Celsius. the answer was, oh, sorry. For the question before, the answer was A, the first one. So it would be this one.
Thank you.
Okay, so for this one, the easiest thing to do is to draw a temperature diagram. So it's going to look something like this. So we're starting off at a high temperature, which is going to be the 143 degrees Celsius. Oops. So we know water boils, so this is going to be our transition stage where water is going to be boiling. And then that's going to be 100 degrees Celsius. And then we're going to go down to 34 degrees Celsius. Okay, so from this range, we're going to be using the Q equals to what? You guys remember the equation? Okay, so we're going to be using Q equals mc delta T. Okay, so the fact that we're going from one transition state, so we're steam, and we're going down to we're getting ready to make our transition. So that's going to be our change in temperature. So that's going to be like the hint that we're going to be using. So that's going to be when it's in steam form. So we're going to use a specific heat for steam. So I'm just going to put CS for steam. And then for our transition state, this one, we're going to use Q equals M delta H. And that's vapor. And then for this one, we're going to use Q3 is going to be equal to MC, and this will be liquid or water, delta T. Okay, so then we're going to go ahead and plug everything into where they're supposed to be. So we have 27 degrees, 27 grams times our C for steam, which is 2.0, and that's joules per gram degrees Celsius, times the change in temperature, which is 143 minus 100. So we get 27 times 2 times 43. So that'll be 2,322 or 2,300 joules. Here, this one is going to be 27 grams times our heat of vaporization. Now, the thing is that this is in kilojoules, so we should change that to joules. So if we multiply this by 1,000 up top, then we end up with 2,260, and that would be joules per gram. So that one is going to be 61,000 joules. And then the third step is going to be 27 times the specific heat of liquid or water, which is 4.18 joules per grams degrees Celsius, times our change in temperature, which is going to be 100 minus 34. So we have 2 sig figs, so that's going to be 7,400 joules. So if we add them all together, our Q total is going to be Q1 plus Q2 plus Q3.
Is it 158,000? No, 15,800?
Let's see, hold on.
No, no.
I got 70,
Yeah, it's more because there's 61.
71. Yeah, 71,000. And that's joules. Change that to kilojoules. It should be 71 kilojoules.
Okay.
Okay. Yeah, because it's 2,300 here plus 61,000 plus 7,400.
Yeah, I put 6,100. That's what I came up with.
Okay. Be clear. How are you guys doing? Tired yet?
Yes.
Okay. So number 25 is going to be very similar to the one that we just did. 26. So you're going to identify which solution are homogeneous solutions. Rum and Coke, homogeneous.
Yes.
Sweat.
No.
Okay. Oil and vinegar.
No.
No.
No. Tea with boba.
No.
No.
Distilled water.
Yes.
Mhm.
Ethanol.
Yes.
Okay. Okay, so let's talk about the truth though. Rum and Coke would be a mixture because it says a homogeneous mixture. It didn't say homogeneous. Homogeneous mixture. So distilled water is pure. Ethanol is pure. So your correct answer would be your rum and Coke because mixture. Mixture means you have two or more different things.
Okay.
Make sense?
So it's just the first one on that one?
Yep. So rum and Coke would be the only one.
Okay.
Let's see. Identify whether the object is macroscopic or microscopic or particulate. Plant cell.
Microscopic.
Okay. And sugar or C6H12O6.
Microscopic?
Particulate.
Microscopic, particulate. That's right.
Oh, particulate.
Yep.
But you can see sugar.
A single sugar molecule.
No.
Oh, no. I was like, you can see sugar. I was like, how is that? Okay.
If I just said a bowl of sugar.
Mm-hmm.
Okay, determine if CO2 is a molecule, compound, or slash and element. And or.
A compound.
Anything else?
No.
Are you sure? What is the definition of a molecule?
Um,
Would it be a compound and a molecule?
It would
Yeah.
actually be a compound and a molecule. Yes. Definition of a molecule is two or more atoms. Definition of a compound is two or more different atoms. So, isn't CO2 two or more atoms?
Yes.
Yeah.
Okay. Good job. How many of you guys got 100%?
No.
No.
So, you're able to do the exam another time too.
Everything?
We had 2 attempts?
What was that? So,
So
yeah,
we-
technically, you have 2 attempts for the exam.
Okay. So then you'll just keep like the highest score?
Yeah.
Okay.
Do,
So,
do we have
Okay.
access to this recording to study from?
Yeah, I will be posting the recording. It'll probably post tomorrow. Because first they have to download it and then they'll put in the system. What you guys, yeah. We'll post it up tomorrow. So
for the text correction, does it mean we should do everything from 1 to 28?
for your test corrections,
Yeah.
no, you only do the ones that you've gotten wrong for your test corrections.
Okay.
Okay.
And we only have one test correction, correct, right?
That is correct.
Okay, so it's only 1 per test, right?
No, it's one. You get one.
Oh, we get to pick. Oh,
Yes.
okay.
Yeah. Yeah, so you wanna make sure, like, if you really bomb the first one, then you use your test correction for that. But if you, let's say you did decent, let's say you got a 70 or something like that, I would save it just in case.
And the test is due on Friday?
Okay, so technically your test is due on Friday. However, your test will be remaining open without penalty, long as you get it done before April. Okay, so it has to be done before April 1st, your exam. Okay.
What about the second lab? Is it due this Saturday?
Yeah, so your second lab, you should have already done your second lab and your third lab. You should be on your third lab right now.
Yeah.
And so,
Okay.
but all your labs, all your homeworks, everything is going to be opened up for you guys.
Okay.
To do over the break.
Thank you.
And I'm not giving you guys anything more to do because technically, like I said, your exam is on Friday. So technically, you can get your exam done. You don't have anything to do. Now, if you're behind or you want to get ahead or anything like that, I will be opening up the test tools. That will be that first thing you get back. And then I will also open up all your past assignments. So you'll have the opportunity to do all of those.
Okay, thank you.